All right, you are welcome again. Let's take a look at this question. Evaluate the integral of x squared all over x plus 1 dx. Okay, we are asked to evaluate this. Let's see how we're going to do it. That means we're going to say, let this x plus 1 being a denominator, let's call it a letter u. Okay, so that means we're going to say let u equal to x plus 1. And then we find the derivative of this u with respect to x. That is, we say du dx is equal to, when we differentiate, it's going to give us 1. When we differentiate x, it gives us 1. All right, good. Now let's cross multiply. In doing so, we are going to have du is equal to dx. Okay, now we said x plus 1 be called the letter u. That means in place of x plus 1, we replace it with u. And in place of dx, we write du. Okay, good. But the challenge we are going to have now is, what are we going to write in the place of x squared? Changing the variable from x to u. But then, in the numerator, x squared is still there, which is not proper. So what are we going to do? Now let's go. We have u is equal to x plus 1, right? Good. Let's make x the subject here. That means we take 1 to the other side. We have u minus 1 is equal to x. Okay? So that means in place of that x squared, we replace it with the value of x. Okay? Then we'll have x squared. Now let's go. We have the integral of x squared all over x plus 1 dx, right? Good. Now let's go. In place of x now, we write u minus 1, but we have x squared, right? That means we have u minus 1 squared all over u du. Okay? In place of x plus 1, we write u, and in place of the x, we write du. Okay? Good. Now, in our numerator, where we have u minus 1 squared, it's the same as opening it into two places, where you say x times x will give you x squared. Okay, so in this case now we have u minus 1 squared. That means you open it into two places. So that means we're going to have the integral of u minus 1 in bracket times u minus 1 in bracket all over u du. Okay, good. Now let's multiply our numerator. When you multiply our numerator, we're going to have the integral of u squared minus 2u plus 1 all over u du. Okay, good. Let's split these into 3. Splitting them into 3 is the same thing as saying u squared all over u minus 2u all over u plus 1 all over u du. Okay, because if you combine these 3 together, it will give you the same expression as above. Now let's go. When you say u squared all over u will cancel 1u under. Okay, that means we're going to have u squared divided by u will give you u, right? Good. And when you say minus 2u all over u, or minus 2u divided by u will cancel u, and then we have minus 2, and then we have 1 all over u du. Let's take the integral of the individual terms. That means we're going to have the integral of u du minus the integral of 2 du plus the integral of 1 all over u du. Let's integrate properly. That means in integrating u, we're going to have u squared all over 2. Then minus, in the place of integral of 2 du, we're going to have 2u plus the integral of 1 all over u is going to give us ln u. Then we have plus c. All right, so as we integrate, we are having u squared all over 2 minus 2u plus ln u plus c. Now let's combine these first two terms. This u squared all over 2 minus 2u. Combining them together, look for the LCM. That means we're going to have u squared minus 4u all over 2 plus ln u plus c. All right, yes, but you recall that u is equal to x plus 1. So in place of u now, we replace it with x plus 1. All right, good. That means we are going to have x plus 1 in bracket squared minus 4x plus 1 all over 2 plus ln x plus 1 plus c. Okay, now in this place we will have x plus 1 squared. In simplifying this, we are going to have x squared plus 2x plus 1. Okay, and then let's use 4 to multiply the brackets. That means we're going to have minus open bracket 4x plus 4 all over 2 plus ln x plus 1 in bracket plus c. All right, good. Now let's open the brackets. Okay, in opening the brackets, in our numerator, we're going to have x squared plus 2x plus 1 minus 4x minus 4 all over 2 plus ln x plus 1 in bracket plus c. Okay, good. Look carefully in our numerator. When you say 2x minus 4x, it's going to give us minus 2x. And when you say 1 minus 4, it's going to give us minus 3. Okay, so here we have x squared minus 2x minus 3 all over 2 plus ln x plus 1 in bracket plus c. Okay, let's also split this our first term into 3 now. Splitting them into 3 or splitting it into 3, we're going to have x squared all over 2 minus 2x all over 2 minus 3 all over 2 plus ln x plus 1 in bracket plus c. Okay, good. Now let's go. Here we have x squared all over 2 minus, in this place we have 2x all over 2. 2 will cancel 2. We are going to be left with minus x. And then in this place we have minus 3 all over 2. We see that minus 3 all over 2 is a constant. Okay, it's just a number. And we already have a constant, c. That is, we already have something to represent the number, which is c, as a constant. So it will not be proper if we still have minus 3 all over 2 and still have a letter representing a constant. Do you get? So that means we eliminate this minus 3 all over 2 because this c have covered the constant that it is. Okay, so that means we do away with minus 3 all over 2. So here we have x squared all over 2 minus x plus ln x plus 1 in bracket plus c. Okay, you can stop here or you can still go further and then combine these first and second term together. Okay, when you combine, you are going to have x squared minus 2x all over 2. Okay, that is when you look for the LCM and then combine, we're going to have x squared minus 2x all over 2 plus ln x plus 1 in bracket plus c. You can also leave it this way or you go further and say let's factor out x. Factoring out x in our numerator, we're going to have x open bracket x minus 2 close the bracket all over 2 plus ln x plus 1 in bracket plus c. All right, yes, this is the final answer. This 1 2 3, these 3 last steps, they are all the same. Okay, and they are the answer to the integral of x squared all over x plus 1 dx. Okay, so we have evaluated and we found the proper integral of the expression we have. Yes, thank you very much for watching. Please, let's take more examples. If you like this video, please give it a thumb up. Subscribe if you have not. Like and share our videos. Stay blessed.